But we'll get a start on it. At least we get some vocabulary done. So the next topic is scalars and vectors. Both words you might know. Maybe you know these words. You recognize these words? Yeah? Okay, so scalars and vectors. Right, so a scalar is a quantity that has only magnitude. So this means a scalar is just a number. It has a size. That's all. It has no direction. It's just a number. For example, so here's some examples of scalars. Walking at 1 step per second. That's a scalar. But walking at 1 step per second to my home, that's not a scalar. And the difference is what? The direction to the home. Okay. Other examples of scalars, 1 kilogram, that's the mass of the cup. 20 centimeters, that's the length of the pen. These are all scalars. Okay, so the key definition here is a scalar is a quantity that has only magnitude. You should write this down because this is an exam definition, of course. It's a classic physics exam question. What is a scalar? A scalar has a quantity that has only magnitude and no direction. So you don't need to write the example down. This is enough for the definition. Okay? You have that? Okay, next. So of course, what's the next one? Vector. So a vector is a quantity that has a magnitude and direction. So for example, walking at 1 step per second to my home is a vector. However, walking at 1 step per second is not a vector. It's a scalar. It's missing the direction here. So in the exam, they sometimes ask for an example, but usually not. Usually the question is something like, give the definition of a scalar and a vector. Something like this. Okay? So they're nearly the same. The only difference is the direction. The two most well-known examples of scalars and vectors are speed and velocities. Most native speakers think speed and velocity is the same thing, but they're actually very different. So speed, is it a scalar or a vector? I wonder if you know. It's a scalar. Speed of an object is the change in the distance per time. So for example, 50 kilometers per hour, that's a scalar, that's speed. Or 10 meters per second, that's a scalar, that's speed. Or 1 step per second. These are all speeds. As a formula, speed is distance travelled over time taken. Okay, so I'll give you a minute to write this down. So this is speed. So I didn't actually say it here, but speed is a scalar. Okay, so next is going to be velocity. Velocity has only one difference in the definition. Does anyone know the difference? True, yeah, so it's
change of displacement.
That's the displacement instead of distance, yeah. So I should explain the difference now, just to be clear with the English. So if I said here's A, here's B, and this is 10 meters, this is called distance, yeah, and then displacement. Yeah, kind of like that, yeah, so like the displacement is also 10. So it seems like it's nearly the same, but let me give you an example of when it's different. So for example, if we have a man here, and let's say he walks 10 meters this way, 5 meters this way, and then 5 meters back this way. So in total, his distance travelled is 20 meters. However, the man is here now. His displacement is only 10. Can you see the difference? Yeah? So what would happen if the man walks 10 and then 10?
0.
Yeah, displacement would be 0, but distance would be 20. So velocity is the change in displacement over time. For example, 50 kilometers per hour due north, or 10 meters per second to the finish line, or 1 step per second to my home. These are all velocities, and as a formula, velocity is change of displacement over time taken. So it's nearly the same, but the big difference is direction is what you need for velocity. Okay, you have this? Actually, maybe we will get this one finished because there's not as much in it as the last one. Do people know this word, homebound?
No.
Homebound means in the direction of my home. So you could say schoolbound, meaning you're heading to school. I don't know, this is maybe new? Yeah. Okay. More to follow. Right, so we talked about displacement. Displacement is a vector. It's the position of an object at a point in time. For example, the ship is 2 kilometers to the east, or the man is 3 kilometers to the east of his home. These are all displacements. So, another displacement. He is 1 meter in front of me. That's a displacement because I'm telling you where he is compared to me. Yeah. So displacement is a lot like position, where something is. Yeah. Okay. So all you really need is displacement is a vector. It is a position usually at a point in time. Okay. So terms like homebound and to the finish line, although our directions, they're not very mathematical, we need something more precise. So often vectors are given to us as a magnitude and an angle, which represents the vector. So basically, the best way to represent a vector is with an arrow. Okay? So we don't say 2 meters per second to my home. We can draw it as a vector, as an arrow, like this. So what this would mean is you're moving this way, and the length of the arrow is how fast you're moving. So for example, with the picture of my man, if I say his velocity is this, and then here, if I say her velocity is this, in both cases, which way are they heading? North. But because I draw this twice as big as this, it means she's going 2 times faster. So the length is the magnitude, how big, and the direction is where it points. Yeah?
As a factor or further?
Well, in this case, these are representing velocities. Yeah, and then after some time, let's say 1 hour later, yeah, like maybe he's here and she's here. So this could be his displacement and this could be her displacement. So after 1 hour, the displacement will also be twice as big, yeah. This is called the tail of the vector and this is called the head of the vector. So this I would like you to draw for the vocabulary. The length represents the magnitude and where it's pointing represents the direction. Got that? Yeah. Now, what do you think? Do vectors have units? What do we think?
Do vectors have units?
Yeah.
Yes.
They do, yeah, because if it's displacement, what's the unit? Meters. If it's velocity, what's the unit? Meters per second. So the magnitude, the vector, it has a unit. So for example, in my picture here, this could be 2 meters per second, and this one could be 4 meters per second, or something like this. And then maybe later this is 1 kilometer, and this is 2 kilometers, or something like this. So in other words, these have units. They do have units. Okay. Here's some basic questions, just to practice drawing them. So let's draw them together. Okay, so the first one, 5 meters per second north. So let's draw it here. This could be 5 meters per second north. So this is for part A. So if that's 5 meters per second north, then 4 meters per second east, that should be this way, but not quite as long as this one. That would be B. 5 meters per second west, that would be the same length here. We'll just draw it here to the west. C. Okay, so this is all fine. And 1 meter per second south, so that would be quite small. So let me just put it here. Be something like this. That'd be D. Yeah. Now, these ones you should write down because you have to be very careful with the English here. 30 degrees north of east.
You're heading east and then you turn to
Yeah, you start with the, let me put it here. And how big is it? 3. So it's about this one here. 30 degrees north of east means the 30 is here. This is the east and this is the north. Okay, so you might want to write that one down. That might be new. What about the next one? North 30 degrees west.
north and then west.
How much west? 30. So this would be it here. This is, whoops, this is E and this is F then. Okay. Right, what about this one? Bearing 30 degrees.
Bearing is north and then you turn clockwise.
That's it. And what's the size? 1. So it'd be like here, and this is 30 degrees, and that's G. And finally, I might have to draw it over here. So I'm out of space. 2 meters per second at 30 degrees.
First quadrant, 30 degrees.
Yeah, so we start here and we go 30 degrees this way from the x-axis, and that's for h. So what I really wanted you to learn in this question is just the different ways we can express the angles.
Could you just repeat G?
Yeah, G, when we use the word bearing, it means we start at north and we go with the clockwise. If I don't mention any reference to north, south, east or west, like in the last example, then we start at the east and go anti-clockwise, like here, measure, like from the x-axis, measure up. Yeah. So yeah, this one, you should make some note on how to read these. They could use anyone in the exam, but usually for the exam it would be this one here. Okay, but you should know the different ways to express the angles. Yeah. Which one would you have used in school?
First two.
These two? Never used bearing before? No? Okay. Alright, can you make some note of that, please? Yeah. So basically this one here, north of east, means start at the east and measure to the north. This one here means start at the north and measure towards the west. This one here means start at north and go clockwise. And this one here is start at east and go anti-clockwise. Yeah? Okay. Alright. Continue? Yes? Do you need to make some notes of that? Yeah? I assumed you knew north, south, east and west. Yeah. Start from the east, yeah.
Start from the north, is it like pointing downwards or?
Pointing upwards, so it's here it is, G. Start at the north and measure clockwise. Okay. Now, this is what your homework is, and actually it will be homework because there's not time to do it now. The homework is on Moodle, but what some students like to do is they like to take a picture so that they can have it on their phone. You two don't have Moodle accounts yet because you just started today, so you'll need to take a picture on your phone of these questions. But if you want to take a picture of them to have on your phone, you can. You all were able to log into Moodle. So if you go to the physics page, this is the second homework on the physics page. You can take a photo of this, yeah.
The homework is there separately, or we need to open the slide and look for it?
It'll be its own link, yeah. Okay, you're going to open it on Moodle. How did that happen?
Trying to switch off the alarm.
You knocked it off the table? Badly broken?
No, it's just, if the touch screen works, there's
Yeah.
just like the water screen or whatever it's called. Like there are all these colors showing up.
Oh, is that easy to fix? The colours are messed up.
Yeah.
That sounds kind of serious.
Very good.
Was it a new iPhone?
The new Samsung.
New Samsung? How new?
That's 7 Edge. So
That's
like,
pretty,
yeah.
pretty new.
4 months.
Did you have insurance on it?
In Dubai.
Insurance doesn't.
Oh sure, maybe you could post it back then and someone in your family could get it replaced then.
Yeah.
Yeah.
Post office in the Arab Gulf doesn't work the same way it does over here.
No? It might not make it back to the house, is it?
No, rarely it reaches houses.
Really?
You have to go to the post office and pick it up most of the
You
time.
can
Oh,
FedEx-
really?
You can FedEx it though.
FedEx should be safe. Yeah.
FedEx. Well, it's very expensive.
Yes, FedEx is expensive.
I'd be better off fixing it here.
Yeah.
Yeah, there's places that fix them. In fact, there's this shop near the school that does phone repairs.
Yeah.
Do you know where it is?
No.
I'll draw you a little map to show you.
It's right in the junction.
Yeah, right at the junction, yeah. So like,
I think we're taking the Displacement.
oh, you're in here now? Yeah. If this is the school here, just come out the school, turn right, go around the junction, and then right here, there's a shop, a phone shop, Mr. iPhone or something it's called. I think they do repairs here. You could get a price off them to see how much it is. If you feel like it's too much, there'll be more shops in the city centre. How much is the phone? Is it expensive?
It's like 700 euros.
Edge?
Yeah, 700, 800 euros.
So probably anything less than 100 euros to repair is a good price, I think,
Yeah.
for the screen. Yeah, yeah. So anyways, you can see what price he gives you there.
But do you think they'll have like a original screen?
I don't know. You can ask him. Yeah.